What up, everybody? Welcome to another episode of Let's Ask Paul. My name is Paul Abernathy, your host. As always, welcome to the podcast. Hey, if you've never listened to one of my podcasts before, do yourself a favor. Go to any of your favorite listening platforms. It doesn't matter. You can go to Spreaker, Spotify, iPhone, the Apple podcast. You can go to the Google podcast. Just about any popular listening platform, all you got to do is search for Master the NEC podcast, and you'll find our podcast. Of course, our unmistakable logos will let you know you're in the right place. But again, you can listen anywhere. Also, if you haven't done so yet, you can actually listen to our podcast from your mobile device by simply going to www.necchat.com. That's necchat.com. And you can download our mobile app on your phone. But the interesting thing about the URL that's on that page, you can actually right-click it, copy it, and paste it on a browser. And guess what? You can have our app act like a browser page on any of your desktops, laptops, and even tablets. They all work the same. So that's the reason why we changed our apps. So we have a mobile app, but the app is adaptable to use on a desktop. So again, that's why we did what we did, and it just makes it a little more usable for folks, and you can make it as a little icon on your desktop as well if you have a laptop or desktop computer. All right, well, welcome to today's show here at Let's Ask Paul, the series where we answer questions that you submit to us through our free online portal. And if you haven't visited that yet, then just go to paulabernathy.com. It's a free service that we provide here at Electrical Code Academy, and allows you to ask questions, and we will answer those questions for you either in response to an email, or we will answer it in one of the upcoming podcasts like we're doing today. So hopefully that gives you insight on where you need to go and what you need to do for you to be able to get your questions answered by us here at Electrical Code Academy. All right, we're going to look at a couple questions today that were submitted for folks, and they might relate to kind of something that's going on in your life, something in the field that you had questions about, and we're going to try to answer it. I will tell you all of my responses, unless you tell me otherwise, are going to be based on the latest edition of the National Electrical Code. So that means we're going to be working on the 2023 edition of the NEC. So I just want to keep that in mind in case you're wondering, well, what edition is he talking about? Or this is not in my edition. I'm always going to refer to the most currently available edition, whether it's adopted in your area or not. That's what we're going to use. And of course, if you want me to be specific on any cycle, like the 2017, the 2020, the 2023, then make sure in your request over at paulabernathy.com, and make sure you put the code cycle that you're referring to in your question. That way I can kind of answer it more specific to the cycle you're on. Otherwise, I'm going to give you the latest edition. Okay, so today's question came, and I'll read it. It says, "Hey, Paul, I am curious about Article 430.32A1. It says motors with a marked temperature rise of 40 degrees C or less at 125%. Of course, we're talking overloads because we're in Section 32 of Article 430. Okay? And it says, would that include 40 or only everything below? Taking a practice exam that I had a question with a 40 degree C rise, so I used 125%, but got it wrong, and it said I should have used 115%. Thank you in advance." Okay, great question. First thing I'll tell you is this is another example why I tell people sometimes question databases can have some errors. Even ours, because we don't write these questions in our database in our Fast Tracks program. If you're not familiar with our Fast Tracks program, check it out, fasttracksystem.com. If you have a database, sometimes questions can roll over from previous cycles, and the editors or the author of the questions or the database of questions, in this case, the Ray Holder database that's also offered by DeWalt. We purchased that, and it's available to all of our clients. So you don't have to pay extra for that. It's included. So we make that investment for you to help you, and it's over 800 questions. Out of 800 questions, there's about 6 or 7 that are wonky that we disagree with, and the author won't change them. So again, what can you do about it? But that just proves to serve as an example of any educator that puts questions out there, they could make a mistake. So that's why you ask questions. like this person's doing, and we can give you the answers. So I'm going to answer this question for you. So if we go to the National Electrical Code and you have your code books, if you take time to blow the dust off of them, and you go to 430.32, and I'll do that at the same time so I can read it verbatim for you. Okay, so 430.32, so this is for continuous duty motors. So the motor, and the most of the time, the motors you're dealing with, unless they're intermittent duty, periodic duty, things like that, for elevators and other, it'll tell you that. But when it comes to, in this case, exam prep, it's one of those things that you have to look at and go, all right, most all motors are going to be a continuous duty motor unless it states otherwise. And on an exam, typically they're going to be continuous duty, but make sure you read the question and understand it. It looks like in this question they knew it was continuous duty because they were in the 430.32A1, and A1 is under continuous duty. Now, you look at A of 430.32, continuous duty, A1 is more than 1 horsepower. So we got a more than 1 horsepower application here. And you have separate overload devices. So this is devices that are separate from the motor, right? It could be in a separate housing, but it is not part of or integrated within the integral portion of it. That would be a thermal protector or electronically protected as part of the actual motor. And that is actually 430.32A2. So that's not what we got going on here. So if you look at A1, it says separate overload device. It says a separate overload device that is responsive to motor current. Okay. This device shall be selected to trip or shall be rated at not more than, not more than the following percent of the motor's nameplate full load current rating. So that's the first thing we have to remember is when you're dealing with motors, there's different tables you have to be familiar with. And there is tables that you're going to use for when you're doing the short circuit ground fault protection that's given to you in 430.52, but it's going to use what's called the FLC. And that's the full load current from the tables within the NEC. And they're going to be at 430.248, 249, or 250, for example, right? That's what you would use for short circuit ground fault protection. That's what you'd use when you're sizing conductors, whether it's branch or feeders. But that's not what you're typically going to use for overloads. Okay, so you would use the nameplate FLC. So it's got to be posted on the nameplate on that motor. And so that's what you'd be using here. Now, when you look at the table that's specifically underneath it, you're going to see some variables here when it comes to the percentages. Now, notice the first one, it says motor with a marked service rating of 1.15 or greater is going to use 125% of that nameplate FLC. Now, it says for motors with a marked temperature rise of 40 C or less is going to use 125%. Now, all other motors, it's going to use 115. Now, I don't know the entire question, so when you ask me a question like that, there might be more in the question. So here's my advice to folks out there. In your question at paulabernathy.com, make sure you copy and paste the entire question in there and then give your response, because there could be something in the question that we need to address, okay? And in this case, I don't know there is because it seems pretty straightforward. It just probably is a bad question on some kind of practice exam or whatnot out there. And it can happen. So relax. The fact that you're digging deep into it tells me something, tells me you're very dedicated to it and you want to know the difference. That's important. So if we looked at it, looking at this table, since you said the question you're asking, I'll answer that first. It says the motors with a marked temperature rise of 40 degrees C or less at 125%. Would that include 40 or only everything below? So look at it literally what it says. It says motors with a marked temperature rating 40 C or less. So it includes 40 C or less. So it includes 40 C, 39 C, 38 C, 37 C. You get the picture, right? And then, of course, if it was a marked service factor of 1.15 or greater, then it would be 125%. Now, here's the interesting thing. It's going to be 125% if it doesn't give you the temperature rise, right? But it gives you the marked service factor of 1.15 or greater, which includes 1.15 or greater. Then you're going to use the 125. If it's a test question and it doesn't give you either or of these, because you don't have to meet both. You don't have to apply the 125. You don't have to have a marked service factor of 1.15 or greater and a temperature rise of 40 degrees C or less. You don't have to have both of them to kick this 125 in. It's either or. Now, if you have a motor or you have a situation where you can't determine either one of these, then you know that it's going to consider all other motor, and that's going to be 115%. Okay? So I don't know the total aspect of the question. If there was a kicker in there, or you're just asking the question, but it sounds to me like it was a question that was asking about 40 degrees C, and do you apply 125%? And the answer to that is absolutely. So I don't know the details of your question, but you don't have to meet both of these to be 125%. Okay? All right. Hopefully that answers that question for you. Again, if there's a follow-up to this or you want to ask, or anybody has a differing opinion on that, please go to paulabernathy.com and do me a favor and mention this episode and give me your rebuttal. I'd love to hear it. Maybe we'll have a tit for tat session on one of the next Let's Ask Paul segments. Okay. All right. So that's that one. Let's go on now and move on to another question that's been sent in through the queue. All right. Let's see here. I was saying the next question we're going to look at, this is a bit lengthy, so bear with me as I kind of read this out here. It says, Paul, big fan. Thank you for helping us all navigate the NEC and proper electrical installations. I work for a building department in Southern California. One of our inspectors was performing a residential electrical panel release. The panel has KOs for conduit or cable entry at the top and bottom of the panel. However, the contractor drilled a hole on the side of the panel. I did not gather why, but our inspector has written the correction that this has violated the listing. Okay, now we're going to talk about that, but let me read a little more. It says, I looked into the NEC, researching the topic, but the only thing I could find is installation instructions that read, remove only those KOs or knockouts required for installation of cable clamps and conduit. Remove center knockout, top or bottom, by 1 driving inward, 2 prying up or driving in the rings 1 at a time, and 3 using pliers to bend rings back and forth until detached. Knockouts are used to pull cable into enclosure to prevent damage to installation. Use only approved clamps, conduit, and fittings. From reading this, I can only assume that drilling additional holes at other locations that is not prescribed by the manufacturers are prohibited, even though it doesn't read that you cannot. Can you please clarify this? I have read forums where contractors have run into similar situations in other jurisdictions, but I did not find anything conclusive. We're in the business of applying the code and ensuring proper installation, but we also don't want to make things up and want to get it right. As for now, we are enforcing the requirement that the hole is not permitted and that only the KOs can be used as prescribed by the manufacturer. Looking forward to your answers. Thank you. Okay, good question. And I'm going to tell you a couple things in here that, people may or may not agree with. And I am, if anything, controversial for some cases. Now, the interesting thing is that if you look at Article 314 in the NEC, which covers enclosures, you're not going to see any .6 in there that requires them to be listed. Okay. Now, there is a listing for enclosures for electrical equipment. That's UL 50. And for those electrical equipment that's in environmental considerations, then that would be UL 50E. And so in that, we would look, and you really talks about KOs, which are physical knockouts, right? So when a manufacturer produces that, now that's another thing that we should talk about, listings. So you really don't ever lose a listing, right? You can violate a listing, but you never lose a listing because the listing is afforded to the manufacturer who produces a product in accordance with its listing, and then they sell it to the end user. So as far as the manufacturer goes, they never lose their listing. You modify something in the field, you may or may not have to get what's called a field evaluation from a field evaluating body to come out and reevaluate something in the field. So one of those type of things is I'm going to address a couple of these pieces here in this whole thing now. Now, the little document that comes from the manufacturer, that is describing how you utilize KOs. It didn't prohibit you from drilling holes. And you remember, they sell cabinets with no holes in them. And, commercial is very prominent, and you have to put the holes in. Of course, you have to remember things that are for routing and where you put any components that are in there and all this type of stuff, because you have to have certain bending radiuses and clearances from terminations. We get all of those little things that are covered in 312.6, right? And so typically the manufacturers take care of that for you, so you don't have to worry too much about that. But if you go drilling your own holes, and depending on where you put them, if you got a panel board in there, which is under UL 67, and that's for the panel board, by the way, not the cabinet, it's the panel board, the guts. If you put that in there and you drill into the side and you don't have the proper clearance between sidewall and termination, then that becomes an issue. And that's a tough thing for the AHJ because, they don't know that all those rules the same way, although they can go through the code and do measurements in 312.6 and try to achieve that. But to me, there is nothing that would prohibit drilling the hole as long as you can still comply with the NEC. Just because there's you run into a situation where you have pre-punched holes, but based on your installation, you might need to add additional holes to this. Now, the thing about residential is if that panel is designed to be recessed, so it's in the wall, and of course you're going to have a 2x4 on either side of it, it's pretty hard to bore a hole and be able to do it. But I think if you did it and you put the proper fitting on it and you filled the hole properly with the proper fitting and did everything you're supposed to do, I don't necessarily think that violates anything. So my advice on this one is probably going to be, look, as an AHJ, again, you need to protect your interest. I wouldn't be too much of a butthole about it. If it's just one or two and they're near the bottom or the top and they're really not coming in where they would be running straight into a overcurrent device or something like that. Or if you're trying to make a connection in the back, obviously you don't want to do it, near the bus bar, right? That would be a problem because then that would be altering the equipment that way if you're altering the bus bar. And that has its own UL 67 listing as well. So there is a lot of cases where people have a panel and there's no knockouts in the back, but they have to come into the back. And now remember, I am much more of a proponent for somebody drilling holes, be honest with you, than I am for them to come through one big knockout in the back with all of the cables through one big 2-inch TA. That's a violation of the code. So what do we tell you? You need to bring your cables through the openings in the back, right? And at the end of the day, people say, well, that'd be violating the listing of the cabinet. Well, I don't necessarily think that violates the listing of the cabinet. There's actually nothing in UL 50 that states anything. Now, if it's a KO from the manufacturer, then they have certain rules that they have to follow with how the KOs are made, right? And then the location as far as a manufacturer goes. But I don't necessarily think that would cause any issue. It certainly wouldn't cause any major red flags to me. As long as the KO was punched in a location, it's not going to compromise its separation in 312.6 and those rules. And the manufacturers already take care of this for you when they put in the KOs. But that doesn't come into play when you're dealing with a cabinet, for example, that has no KOs in it and you got to drill your own or punch your own. Then you're on your own, but you're certainly not violating any cabinet rules. In fact, UL 50 is pretty loose because that's talking about enclosures for electrical equipment. So you'd follow that. But in general, there's no requirement, for example, for boxes to be listed unless the box is for a specific application, like a floor box. Then you get a listed floor box. But you'll go look in 314, you're not going to see a listing requirement there. But that doesn't mean that you don't have certain boxes that are listed or they're identified for a specific use, and that's from the manufacturer, right? So you do have that. So some of my advice, if you're an AHJ and you're concerned about this, there's a simple thing you can do, is simply tell the customer, I'm typically not going to have a problem with this, but here's what I need you to do. All you got to do is reach out to the manufacturer. And most all manufacturers have the ability to reach out and contact to them. Or you could contact NEMA. I recommend you reach out to your NEMA field rep. Okay, that's what they do. They interact with the manufacturers. The NEMA reps are all available at NEMA.org. And that's what they're there for. And ask them to get you that information and put them to work. I mean, I was a former NEMA representative, and that's what we do. And I don't think people utilize them nearly as much as they should, because they have a direct line to the manufacturer, and they can help you with these questions, right? And of course, if they don't help you, then you can complain. And trust me, these folks don't want complaints. So you can complain to NEMA directly. So trust me, the NEMA reps are great guys. They will definitely help you out. But here's what I would do. I would tell the contractor, I'm like, okay, I'm going to let you keep going right now. But before I can give you the final, I need you to have something from the manufacturer that says that it's okay to put holes in the side of this equipment. If that concerns you. Now, I'm saying as an AHJ for years, I don't feel that it violates any listing. Okay. I don't believe there's a listing on that cabinet. All right. I believe there's a listing on the panel board. And as long as you don't alter the panel board, or if you follow the rules in 312 for cabinets, and I might have inadvertently said 314 a little while ago, but that's for boxes. But if you violate the listing for 312, then, there's nothing in there that says they have to be listed. Okay. So, as an assembly, manufacturers get things listed. UL 67, again, like I said, for panel boards. But the panel board's the guts. It's not the entire cabinet. Okay, you put the panel board in a cabinet. So when the manufacturer does that, they're looking at the cabinet. They're making sure of the size, standardized sizing. They're putting the panel board in there. They're making sure they have clearances to the left and to the right if you have KOs coming in, things like that. But definitely, if it concerns you, then I would go on and tell them to reach out to the NEMA rep, or they can contact their local sales, wherever they bought the panel, and tell them they got a huge issue. The manufacturers are there. I mean, I work for Encore. You can reach me anytime at Encore to get the Encore or get our opinion on something, that type of thing. But I personally don't think that violates any listing. Again, I would make sure where they're entering it, things like that. Now, with that caveat, I will say some other things. If you have a panel, for example, that has a rating, like, for example, there's the NEMA 1, the NEMA 2, NEMA 3Rs, things like that. If you do something that's going to circumvent the rating, the NEMA rating of that panel, and can create other issues, because if you have a panel that's going to be in a wet location or a damp location or something like that, then it has a specific rating for that enclosure. And penetrating it can violate the rating of that enclosure. And there's certain things that you can't do when it comes to that. For example, if I have a NEMA 3R in the top, and it's a hub entry at the top, and it's a special top, I typically can't just willy-nilly drill holes in the top if I'm provided a hub to do that. But you could reach out to the manufacturer and electricians. If you're going to do something like that, make the call. And it can really save you a bunch of headache down the road, that type of thing. But that's about the best I'm going to give you an answer for that. The manufacturers are there to help you. But there is a difference between a hole and a KO. Okay, so I just want to make that clear to folks. The manufacturers that put the KOs have to follow the rules for the KO, and they're going to give you instructions on the KO and how to remove the KO and all that. So don't let that confuse you with getting a cabinet that actually has no holes in it, and this is very common in industrial and commercial, that you have to add your holes. But then you have to be keenly aware of 312.6 when you put any equipment inside of it to make sure that you have that clearance for bending of conductors at terminations and all that. So, I mean, there's a lot of things to think about. This is why we typically, when you residential, it's pretty much done. You think that it's done for you. But again, as long as you did it above or below and you didn't have any integrity onto the panel board, or you didn't affect any of the guts or anything like that, or didn't affect where the bus is going to go or the grounded conductor bus, then I probably would have zero problem with you coming in to the side. Okay? All right. And then incidentally, a lot of panels already have KOs in the side, but because they're pre-punched, they're KOs, but that doesn't prohibit you from adding your own. You just have to follow the instructions for removing theirs that they provide for you, that type of thing. Okay. All right. Hopefully that answered that question, or at least gave you some additional insight. You probably were looking for a definitive thing, but that's, you know what? That's the best I can do for you for that situation. Okay. All right. Well, we're doing pretty good in time here. Got knocked out 2. Let's go on and get another one. This is another lengthy one, and it's got a lot of different weaves and bobs in it here. So if you're into PV photovoltaics, then this one is the one you're going to hang around and listen to. If you're just starting to dabble in that, it's getting real popular now. I'm not a big fan of it, but it does create a lot of potential jobs as we grow in this energy sector. Gets even greater and greater. So I'm going to read it here. So, hey, Paul, I'm deep in my studies for the master's test here in Iowa under the 2020 NEC. And yes, using the Fast Tracks Black. Well, congratulations for being in our program. And it says, my question, however, will likely not be applicable for a test, but something related to work I do in the field. I work in solar. I started in commercial and made the switch 6 or so years ago and love it. I work on projects big and small, commercial and residential, and often work with battery systems. Okay. So it sounds like you have some backup systems and you like to work with the batteries, maybe Tesla walls, or maybe it's a Generac battery backup. Nobody's using lead acid stuff anymore, I don't think. I mean, I don't know. I'm not totally in touch with that industry anymore. So, but anyway, it seems like that would be so antiquated now with the lithiums and all that stuff we have. Anyway, my question is in regards to the equipment grounding conductor. It says the rule of thumb that was taught to me by those with authority at the time was 6 copper all the time. Okay. Well, first of all, since it's an EGC equipment grounding conductor, if that's the question you're asking about, it might be germane to what they do, and it doesn't have to be larger than that because of the sizes they're dealing with. And that might be, for example, larger than needed anyway. So they just kind of might be their policy just to, hey, don't worry about it, always go with 6. I'm not sure, but that is the problem with rule of thumbs, is that nobody knows how they ever got there. They're just what people say, right? Okay, and it also might be that typically a lot of times you have to put some protection on things that would be smaller than 6, like 8 and less, for damage to it or things like that. And so they go with 6, and then they feel better because it's exposed. But that's typically for the grounding electrode conductor aspect, because typically the EGC equipment grounding conductor is run with the circuit conductors, or it's the raceway itself if it complies with 250-118, right? So, it might be a mixture in this understanding the difference between EGCs and GEC that helps get into that confusion there. I'm not sure, but we're going to keep on reading here. It says, and then it was 6 copper for DC coupled systems and 8 copper for AC systems like microinverters. Now that'd be rather large for a microinverter. But anyway, it says, now I think it's all BS, and you should size your equipment ground in accordance with chart 250.166. Okay. It says in relation to the size of the overcurrent. All right. So first thing I want to do, I still got more to read for this question, but I need to clarify some few things. So if we go to 250.166 really quickly, you've got your code book because he made a reference to that when it came to equipment grounding conductor. That's why I want to go there real quick to clear that up. Okay. So if you go to 250 and you go to 166, okay, and this is purely for the listener, okay, so I can, kind of keep us on the straight and narrow here. If you go look at 250.166, we're talking about the grounding electrode conductor. Okay, so this is not talking about an equipment grounding conductor. Okay, so we want to make sure that's, again, the terminologies that can get confusing when we're doing that. Okay, all right, so that type of thing. So the equipment grounding conductor, you're going to run with the circuit conductors, and the code for PV is going to allow you, for example, microinverters, in with the conductors that are coming off of the microinverters, which is going to be AC. Then you have a normal equipment grounding conductor, right? And you would size that based on the overcurrent protection aspect of it, okay? So we're not talking about, there's two different things going on in this question. There's the GEC, grounding electrode conductor for the system. That's grounding the system, lightning, transients, what have you. And then there's the equipment grounding conductor aspect of the question. That's to clear any overcurrent protected devices and things like that. And it does do bonding within the system, okay? So again, we'll look at it, but I want to make sure that our terminologies are kind of going straight. All right, let me read on even a little more here. And the reason I had to clarify that is because he stated equipment ground in 250.66, and then he went in relation to the size of the overcurrent, and that is not what's going on here, because 250.166 has nothing to do with the overcurrent, okay? I just want to make that clear in the statement for the individual that might be listening to that. Okay. It says, but there is a section escaping me now without the book in front of me. It states that DC systems do require a 6 on the roof or at the rail that supports the solar panel. A 6 solid copper is used to bond the rail. I believe this is only because that is the smallest size that can be exposed to the elements. Can you clear this up for me? If there are changes from the 2020 to the 2023, it may be worth a mention, but I doubt there are. Thanks for your help. Okay. So we kind of got the lay of the land. We've kind of set you straight on the tables, and we're not really talking about using 250.66 for the equipment grounding conductor. That's for the grounding electrode conductor, right? So you have a couple questions here. One, you talked about the array, right? And the connection to ground at the array. So we're going to talk about that. And then we'll talk a little bit about the equipment ground and the allowances in 690, okay? Because it is going to allow it to modify and supplement information that's in 250, okay? So that's what we're going to do now. All right, number one, let's go on and knock the DC grounding electrode conductor out of the way, since we're already in 250. Let's go on and knock that away first. All right, so your questions about sizes. Since, you're kind of really not asking about the EGC. All of your stuff here, you might make reference to equipment ground, but you really seems like you're talking about the grounding electrode conductor, okay? So first, let's determine sizing, and then we'll see in the code whether or not one is required and where it's required, okay? All right, so 250.66 is the DC grounding electrode conductor, okay, as opposed to AC, which would be 250.66, right? And the rules are pretty similar in a sense, because it does give you, some allowances for when you're taking the DC GEC to like a rod, pipe, or plate, or to a concrete encased electrode, or to a ground ring. So that's very similar to what you have in an AC system for those under 250.66 A, B, and C. Okay, which you would use if you had those type of electrodes. And of course, remember, if you don't have those type of electrodes, like you're using a water pipe or in-ground steel, not a concrete encased electrode, but a different, like in-ground steel, where you have 10 foot of rebar in contact with the earth. That's not. It's part of the in steel, not rebar. Excuse me. The structural steel, like I-beams going down into the earth, whether they're encased or not. So that's in-ground steel. And all of those things like water pipe and in-ground steel and tanks, and you're going to go to the table 250.66, right, to size the grounding electrode conductor for that. Now, if you had pipe, rod, or plate, or concrete encased electrode, or ground rings, and I should clarify, the in-ground steel is like taking the I-beam of a building and driving into the earth. That's an in-ground electrode. The rebar I just mentioned, that's actually the concrete encased electrode, and you would be able to use the allowances in 250.66b if you were dealing with an AC system. And in that case, it's not required to be larger than a 4 AWG copper. Then you're okay, right? It could be less depending on the size of the conductors that are supplying the system, but it doesn't have to be larger than a 4, okay, copper. Okay, so all right, so very similar up here for DC systems. So let's look at it. So 250.66, it says the size of a grounding electric conductor for a DC system shall be as specified in 250.66a and b, except as permitted in 250.66c through e. And that's the allowances for rod, pipe, and plates, concrete, and in-ground ring. Okay, that's the allowances. They're permitted. They're not exceptions. They're permitted sizing. But if it doesn't apply, then you just got to go and follow the rules in A and B. Now, here's what they say. And it also goes on to say the grounding electroconductor for a DC system shall be sized. Sizing requirements in this section shall not be required to be larger than 3/0 copper or 250 kcm aluminum. So just like we have over for AC systems in 250.66, if you go to the table, let's say you have a water pipe ground and you go to the table, or in-ground steel, you go to the table, then it never has to be larger than 3/0 copper or 250 aluminum. Okay, same here. Okay, so you still have that, it doesn't have to be larger than that. But then you've got A and B. Now, what does A say? All right, it says, it says the grounding electrode conductor for the DC system not smaller than the neutral conductor. So it says where the DC system consists of 3-wire balancer set or a balancer winding with overcurrent protection as provided in 445.12d. Okay. It says the grounding electrode conductor shall not be smaller than the neutral conductor and not smaller than 8 AWG copper or 6 AWG aluminum. Now, if you want to know what the 3-wire balancer sets or a balancer winding with overcurrent, then you know what? There's a guy named Ryan Mayfield who has a channel over on YouTube. Hit him up because that dude understands everything about PV systems. I am not a PV expert. So if you're working with these systems, you'll obviously know what they are. So when an expert like me who teaches broadly the NEC, I'm going to say, hey, I'm not here to teach you what a 3-wire balancer set is or a balance winding thing. I'm here to tell you, if you've got one, this is what the code rules are, okay? If you're in that industry and you're in PV and you're doing a PV installation, you damn sure better know what these are if you're putting them in. Okay, I'm here to tell you what the code is for when it comes to sizing the direct current grounding electrode conductor. Okay, all right. Now, it says, so it can't be smaller than the neutral conductor for these systems. All right, could be larger, but doesn't have to be smaller. It can't be smaller. Now, B says, well, it's not smaller than the largest conductor. Okay, so it says where the DC system is other than, as in 250.66a, which is what we just read, it says the grounding electrode conductor shall not be smaller than the largest conductor supplied by the system, and not smaller than an 8 AWG copper or 6 AWG aluminum. So this might be where you're getting the rule of thumb, or where historically they taught you the rule of thumb here, because again, one of the statements you says that I believe you said, and I'm looking it over real quick. I think you said, it says, then it was 6 copper for a DC coupled system and 8 copper for an AC system like a microinverters. Okay, so if we're not talking about equipment grounds, if we're talking about the GEC, then this is where you're going to get your rule of thumbs. Number 1, not smaller than the neutral conductor. Okay, all right, and again, not smaller than 8 copper or 6 aluminum. And then 2, it's not smaller than the largest conductor. Well, it's hard to do a rule of thumb on that one because, it can't be smaller than the largest conductor. But at the end of the day, no matter what size those are, it cannot be smaller than an 8 AWG copper or 6 AWG aluminum. Okay? So The rules for that in 250.66 are governing the sizes, okay? So now also I will address the fact that you said you don't have your code book handy. For those out there that don't know yet, it's worth the investment to get Link, L-I-N-K. It's NFPA Link. Just go to link.nfpa.org and you'll see it. It is worth the investment, my friend. If you're in the field and you're an electrician in the field and and you want to be able to get to things very quickly in your code, right? So make sure that you get that and you can put it on your phone and you can access the code all the way back to 2008 from your phone. And it's got a lot of other content in there. It's got sometimes you have stuff that's embedded in there that you can read, like little graphics and illustrations and extra enhanced content and things like that. It's only like $120 a year, but dude, that's like if you bought a fresh code book each year. If you use it a lot, you probably need to have a new one each year. I'm just saying. But the ability to be able to get to all that at your fingertips is just a beautiful thing. So I'm a big fan of it. So I encourage folks to think about getting that. And then you wouldn't have a problem. You can go right to it on your phone and see anything right away. Okay, so that kind of addresses that. We're going to also address the other issue about the arrays and things like that. Okay. Now, for the microinverters, that's going to be connected to the equipment ground. That's going to be run with the circuits that are coming, the AC circuits that's coming from the microinverters into the combiners or whatever they're going to have, or however your system is set up. That's going to have their own equipment ground. So that's done, okay? Nothing else you need to do with that. So let's go on and real quick and go to 690 and try to address the other thing. Let's say if you had an array on the rooftop or something like that. Okay, in 690, you're going to be in part 5. Okay, so that's what you're going to be working out of to try to solve all these type of questions. Now, the first thing you're going to be dealing with is 690.43. That's the equipment grounding and bonding. Okay, so this is the first part. And again, your question was more to me deciphered because of the sizes you're talking about. To me, it was more you were asking about the GEC, and I've kind of addressed that and where you need to go for that. Okay, but let's look at it here. So 690.43 is equipment grounding and bonding. It says expose non-current carrying metal parts of a PV module, frame, electrical equipment, and conductor enclosures of a PV system shall be connected to an equipment grounding conductor in accordance with 250.134 or 250.136, regardless of the voltage. Okay, equipment grounding conductors and devices shall comply with 490.43 A through D. Okay, so we're into 690.43. So A through D. So A is photovoltaic module mounting systems and devices. So this is the mounting system that's, let's just say it's on the roof. It says devices and systems used for mounting PV modules that are also used for bonding the modules, maybe the way they're interconnected, the clamps, and sometimes they make special fittings that interconnect the different modules that connect into the framework and all that, okay? Shall be listed, labeled, and identified for bonding PV modules. So that should be taken care of from the manufacturer. The thing that you watch out for is when somebody tries to willy-nilly and make up their own thing using washers or something that's not listed, okay? Not that's actually labeled and that's actually identified for bonding of PV modules. But the manufacturers that provide their clips, their mounting hardware, all of that stuff will be evaluated as part of their system, right? It says devices that mount adjacent PV modules shall be permitted to bond adjacent PV modules. Okay, so if I have one setting and I'm putting a module next to it, and then you have this little bracket that connects the two together, then the manufacturer will have this device will be able to do that and carry that bond over to the next module. Okay, and so it just kind of daisy chains it out. Again, this is all manufacturer specific. The only thing that you have to worry about is people that don't want to use manufacturing hardware, things like that, and then that becomes a more challenging of a task for the AHJ, right? So the next thing it says is B. It says equipment secured to grounded metal supports. It says devices listed and labeled and identified for bonding and grounding the metal parts of PV systems shall be permitted to bond the equipment to grounded metal supports. Okay, so if you have these modules and these arrays, these metal parts of a PV system, and then they get mounted and they're mounted to metal supports, then it's all interconnected together, right? But you have to remember that any of the devices that do this mating have to be listed, labeled, and identified for bonding and grounding of those metal parts of the PV system. So you always want to make sure you're reaching out to your PV supplier, the manufacturer, making sure all the components they're using are going to complete this component of bonding everything together, right? It says metallic support structures shall have identified bonding jumpers connected between separate metal sections, or shall be identified for equipment bonding and shall be connected to the equipment grounding conductor. So remember, you're mounting these modules in a setting, in a framework that might be connected to other grounded metal supports, and you want to make sure the integrity, and you might need bonding jumpers to make sure that all of the integrity is maintained, unless, of course, it's designed in a way that all of that is intimate and it all is part connected together, that type of thing. The next one is C. It says with circuit conductors. Now it says equipment grounding conductors for the PV array and support structure where installed shall be contained within the same raceway, cable, or otherwise run with the PV system conductors where those circuit conductors leave the vicinity of the PV array. Okay, so telling me that I have to have an equipment grounding conductor, and as it says earlier, all those metal parts are connected to an equipment grounding conductor in this type of system, right? And then, of course, you had the last one for this section is bonding. If it's over 250, then the bonding requirements, it sends you to 250.97, which is the same thing that we do, where it's going to tell you need to follow the rules in 250.92, A2, 3, 4, 5, things like that, right? And so it's kind of doesn't regurgitate the methods that you can bond. But just remember, if you're over 250 volts to ground, then you do have to do a little bit of extra, a little bit more than normal, that type of thing, right? All right, so that covers that. Now, that's telling me what I have to connect to an equipment grounding conductor. So 690.45 is going to tell me the size of the equipment grounding conductor, because we haven't addressed that yet. We addressed the size of the GEC earlier, but now we're talking about the equipment grounding conductor, and it says the equipment grounding conductor in a PV system circuit shall be sized in accordance with 250.122, right? And it says where no overcurrent protected device is used in a circuit, an assumed overcurrent device rated in accordance with 690.9b shall be used when applying table 250.122, okay? So if you're not familiar with that, that is 690.9b. That is overcurrent device ratings, and it tells you the different things that you have to follow there. And it talks about not less than 125% of the maximum current calculated in the first step of the process, which was 690.8a and all that. So you follow those rules, okay? And then, of course, then you would go to 250.122 and size what would have normally assumed to be the size of the overcurrent protection if you're sizing it based on 690.9b. Then you would assume, even if there's no overcurrent, depending on your system setup and how it's designed, you're going to have to assume if you did put one, what size would you put? And then you go and you're going to sort out the equipment grounding conductor size. Okay? All right. Now, the last one we'll talk about here is the grounding electrode system, because we spent a lot of time earlier talking about, okay, we assumed we had a grounding electrode system, right? And then we're like, okay, well, this is how we size it, 250.66 for the grounding electrode conductor. Well, we got to look at 690.47, and we're talking about the grounding electrode system. Now, this is broken into 690.47a, and there's a B. Okay, it's pretty straightforward in the 2020 edition of the NEC. I'm not looking at the 2023 yet for this one to see if there's any significant changes. So we're just going to kind of keep it here at the 2020 on this episode. So let's look at it. So there's an A, and it says buildings or structures supporting a PV system. So this is a building that has the PV system installed on the building. And you have to remember, the building already should have a grounding electrode system already, right? You have to have that for the building. That's a fundamental requirement in Article 250, right? And so that's already should be in place. But here's what it says. It says a building or structure supporting a PV system shall utilize, all right, listen to this, folks, shall utilize a grounding electrode system installed in accordance with Part 3 of Article 250. So we've got the building or the structure, and we're mounting this PV system to it. It's telling me that if I'm mounting this system to it, then the grounding electrode system utilized in the building or the structure is going to be the grounding electrode system that we're going to utilize. It doesn't mean I have to run anything separate, even if I was required, depending on the system, whether it was functionally grounded or solidly grounded. If it's on the building, then the building already has a grounding electrode system. At least it should. I mean, that's the whole basis rules in 250, right? So that should take care of itself. Now, it goes on to say, under 690.47a, it says, now, the PV array equipment grounding conductors shall be connected to a grounding electrode system in accordance with Part 7 of Article 250, right? So it's saying that we have that PV array, everything's there, and we're already required to have an equipment grounding conductor to make these connections. And it says, oh, by the way, that equipment grounding conductor needs to make a connection to the grounding electrode system in the building in accordance with, again, Part 7 of Article 250. Okay, so that's pretty common sense. I mean, if you've got the array is actually mounted on a building or structure, again, the rules earlier that we have to have an equipment grounding conductor that's installed, and we even showed you how to do it if you didn't have an overcurrent device ahead of it, okay, how you have to assume some things. But we kind of talked about that, but it's saying where the connection has to be made. Now, no worries here, because typically that connection is going to be made to an equipment grounding conductor, and you have an inverter, and you're going to have the output of the inverter, and you're going to have the equipment ground. It's going to go back, and it's going to make a connection to the system's grounding electrode system. Okay, that's going to usually take care of itself. But it goes on to say this connection shall be made in addition to any other equipment grounding conductor requirements in 690.43c. It says the PV array equipment grounding conductors shall be sized in accordance with 690.45, and we kind of saw that a little while ago. And it also says for specific PV systems, grounding connections permitted in 690.41a, and there's kind of a list there. One of the following conditions shall apply. So we have systems that are considered functionally grounded, and that's the majority of the systems you're going to deal with. And then we have what's called solidly grounded systems. So we have two rules here. So whether or not whatever system you're dealing with, and you're the PV person, you're the one installing it, you know whether you have a solidly grounded system or traditionally what we would have is a functionally grounded system. And here's what you've got. So number one says, and this is kind of new in the 2020, or at least clarified a little bit better in the 2020. So number one is dealing with a functionally grounded system. And there's an informational note here that goes a long way to explaining the functionally grounded aspect of this. But let's just reread it and use the terminology. It's going to make it easier to understand. It says, for a PV system that is not solidly grounded. So let's just rewrite that in our mind. For a PV system that is functionally grounded, the equipment grounding conductor for the output of the PV system, so that is the PV inverter output, where connected to associated distribution equipment, so it's going from the output of the inverter into the electrical system, okay, usually going to an electrical cabinet where the panel board and everything is going to backfeed a breaker, that type of good stuff, right? Typically. It says connected to the associated distribution equipment connected to a grounding electrode system, which would be inherent to the building, shall be permitted to be the only connection to ground for the system. And that's the only connection to ground for that PV system. So if it's a functionally grounded, typically what you're deal with, then that's it. There is no other need to run anything to ground. That's it. It's done by the equipment grounding conductor. Right? And we learned how to size that earlier. Now, what if you're dealing with a solidly grounded PV system? All right, then you look at B. No, not B. You look at 690.47A2 in the 2020 edition of the NEC, and it says, for solidly grounded PV systems, it says, as permitted in 690.41A5, so you're permitted to have a solidly grounded system if you choose. It says the grounded conductor, okay? Because remember now, if it's grounded, then you have a conductor that's intentionally grounded, so it's solidly grounded system. It says the grounded conductor shall be connected to a grounding electrode system by means of a grounding electrode conductor size in accordance with 250.166. And we kind of sized that earlier. But this is requiring you, if you have a solidly grounded system, then that grounded conductor within that system has to make a connection to the grounding electrode system. And it has to do so via a grounding electrode conductor. Okay, and you size it based on 250.66. Pretty straightforward, right? Okay, now the informational note, which I think is a great addition here, and that's really the beautiful thing about informational notes, is some people hate them because they're not really enforceable, but we're not trying to turn the NEC into an instruction manual, but it's always great when the code panel can add certain things, especially in 690, can be quite confusing, okay? We're not all a Ryan Mayfield, right? We're not all a Bill Brooks, right? We're not all a John Wiles, John Wiles. These are people that make PV their only thing, right? That's their thing. So they eat, sleep, and breathe it 24/7. I do not. I can tell you how the code's applied, but you as a PV person who are the qualified expert in your trade, you know how to install PV. You come to me to give you code advice, hoping that you understand the terminologies being used, because I am not somebody that goes out every day and installs PV systems. And that's a rapidly expanding industry. So I can only talk about the code. You have to have the ability to be able to understand these things and grasp it and say, oh, that's what this is meaning. And I get what Paul is saying. But I'm not a PV installer, okay? And I can probably tell you that 99% of the NEC experts out there who give code advice have never installed a PV system. I'm just saying. All right. So anyway, let's look at the informational note. It says the informational notes can be very powerful. It says most PV systems are functionally grounded rather than solidly grounded systems as defined in this code. A functionally grounded PV system with an interactive inverter output, and an interactive inverter means it interacts with the utility. You lose power, the inverter will switch it over, and it switches it over to if you have storage like batteries or something that type of nature. It's interactive. In other words, it can sense when the utility is on or off, and it works that way, right? Okay, it's interactive, utility interactive. All right. Now, let's go on a little more. It says the AC equipment. Okay, I got to read the whole thing in context. So every time I stop to tell you something, I realize I have to go back and read it again. Okay, it says, for functionally grounded PV systems with an interactive inverter output, says the AC equipment grounding conductor, okay, is connected. And again, since it's the output of the inverter, it's taking DC and converting it into AC, okay? Not the other way around, converting AC into DC. It's inverting it. So it's taking DC and turning it into AC. It reminds us that the AC equipment grounding conductor is connected to associated grounded AC distribution equipment. This connection is most often the connection to ground for ground fault protection and equipment grounding of the PV array. Okay, and we talked about that earlier. So again, running the conductors, tying everything together, tying the array to an equipment ground, that's what we're really talking about. If you want to run if a PV system has the array on a building and you want to run, you're permitted to install a grounding electroconductor for that system. Okay. That's your choice. But at the end of the day, that's not required for you to if you have a properly sized equipment grounding conductor bonding all of those components. Okay. Now, the other thing I want to make sure that we know that we are not trying to get into the rules of lightning protection. Okay. That's totally different rules, and we are not trying to dabble in those rules here. We'll let the lightning protection folks deal with their requirements. We're going to deal with our requirements here in the NEC. Okay. All right, folks, that's it for this episode. Again, thanks for listening. If you have anything that you disagree with or you'd like to get into a discussion about it, just go over to www.paulabernathy.com. Know that you can submit a follow-up to this episode. Just make a note of the episode and kind of give me your take on it. I realize in some of these things like PV, I'm kind of talking way out there, but I want to make sure that I went a little bit deeper than the question that was presented. But if any of that was confusing, or you say Paul doesn't know what the hell he's talking about, in that scenario, I get it. It's okay. I can only tell you what the code says. You have to understand how to apply it in that type of thing. So anyway, till next time, folks, stay safe. God bless. And if you got any questions, please go to paulabernathy.com and submit them through the portal. I would do my best to answer them the best I can. You can agree to disagree. It is what it is. But we appreciate your being a part of the program. Till next time, stay safe. God bless.